Namaskar, my name is Sahin Sorifi, and today in this video we are going to talk about unit step function. So you must have heard about this unit step function or Heaviside function. If you haven't, then this will be clear to you today. Before we move forward, let me just tell you that if you are a new visitor to this channel, please subscribe the channel and do not forget to press the bell icon. And our old subscriber, please try to press the bell icon so that you get regular notification. Without further ado, let us just start our video. So we are talking about unit step function or Heaviside function. Unit step, I hope this is visible. So what is a unit step function? It is defined by this u of t minus a. This is 0 when the variable t is less than a, and it picks up the value 1 when you are considering t greater equals to a. Fine. So if you plot this curve, then how will it look like? U of t minus a versus t. So up to t less than a, so up to a, it will remain at 0 level. Once it crosses the value a, it will pick up the value 1. Let's say this is 1, so it will pick up the value 1 and it will remain up to beyond 1, beyond a. Fine. So in this way we define the unit step function. It is also written in this way, u of a function of t. Okay, in this way it is defined. Now our main concern is to know what is its Laplace transform. So if you take the Laplace transform of this unit step function u of t minus a, what will be its value? So you know the basic formula of Laplace transform, 0 to infinity. Okay, f of t means u of t minus a, e to the power minus ft into dt. This is the formula. Okay, so if you calculate that, the limit maybe can be written a to infinity, because 0 to a it is 0, so a to infinity, we are taking this portion, the value is 1, so 1 into to the power minus st dt, and what will it give you? E to the power minus st divided by minus s. If you put the limit a to infinity, the first limit will give you 0, and next limit will give you 1 by e to the power minus as by s. So 1 by s e to the power minus as is a Laplace transform of this unit step function. Okay, so now what will be its Laplace transform if you consider a function like this? So what will be the Laplace transform of, let's say, f of t minus a, u of t minus a? So Laplace transform in this case will be, look, for this f of t minus a, you will get e to the power minus as, and for this u minus ta, it will be f bar of s, where f bar s is the Laplace transform of f of t. Okay, so it's like shifting of origin. Understood? So these two formulas are very important to solve any problem involving unit step function and Laplace. Okay, now let me give you some example. So if we plot this unit step function, so I am giving you one function, so let's try to plot it. The function is given by this, so the function is looking like this. Let's say k into u of t minus 1, okay, minus 2u into t minus 4 plus u t minus 6. Okay, so let's try to draw this function. So in more short notation, you can write, as I told you, u of t minus a, so it is like u1 of t minus 2 u of t minus 4 equals to u4 of t plus u of t minus 6 is like u6 of t. Fine. So let us try to plot this. So we are naming this as function of t, f of t, and we are plotting f of t versus, let's say, t. Now let's start with 0. Okay, so k into u1 into t, so its value is 0 beyond 1, so this is 1, so the function will start like this, and as soon as it crosses 1, the value of t crosses 1, the value of this will be 1 and other terms will remain 0 because they will be activated at t equals to 4, t equals to 6. So it is getting activated at beyond t equals to 1, and activated means it will take a value of 1, so it becomes k into 1, so it becomes k. Let's say this is k, so it will take up the value of k. Now you see minus 2 into u4, so it will remain like this 2, 3, 4, it will go up to 4. So when it crosses 4, it becomes 1. So here 1 minus 2 means minus 1, so it becomes minus k. So it will retain the value of k, and at this point it will become minus k. I hope you understood this, because when you are going beyond t equals to 4, then what happens? This value is 1, this value is 1. So 1 minus 2 into 1, and this is remain 0 because this will be activated at t equals to 6. So 1 minus 2 is minus 1, minus 1 into k minus k. So that is why it is retaining the value of minus k. And it will continue taking up this value until we reach to 6. So it will go like this up to 6. And what will happen beyond 6? Beyond 6, this value is activated. So 1, 1 and minus 2. So 2 minus 2 is 0, so which will become 0. So beyond 6, it will take up the value of 0. So in this way, we can easily plot this function in terms of unit step function. If you are given a unit step function, you can easily plot this one. Now, let me just give you one problem based on this unit step function. So the problem is like this. Let's say we are given a function, something like this. Okay. So a periodic square function f of x is given to you. F of x, which is a periodic square function, and the form is k into u0 of x minus 2ua of x plus 2a of x minus 2u3 of x plus it goes so on. Calculate the Laplace transform of f of x. We have to find out the Laplace transform of f of x. Okay, so how can we calculate it? Laplace transform, we can, Laplace transform is distributed. So k times Laplace transform of this u0 of x, and as I told you the formula, Laplace transform of this ua of x equals to e to the power minus as by s. So we are going to utilize that. So k into Laplace transform u0 x, so e to the power minus as, here a is 0, so 1 by s minus 2 into e to the power minus as by s plus 2 into u2a, so e to the power minus 2a into s divided by s plus, minus 2 into e to the power minus 3a into s by s, and so on. Okay, so you can see we can take 1 by s common, so it becomes 1 minus 2 into e to the power 2, you can take common from here, you are taking s common, you are taking 2 common, you are also taking e to the power minus as common from here. Then what will you get? This term will give you 1 plus e to the power minus as minus e to the power minus 2as plus so on. Okay, third bracket, and this will be equals to k by s into 1 minus 2 e to the power minus as, and this is what, 1 plus x square type thing. So 1 minus x to the power minus 1 is the formula, but here alternate sign is there, so it will be 1 plus x to the power minus 1. So it becomes 1 plus e to the power minus as, and if you calculate that, you will get 1 plus e to the power minus as minus 2 e to the power minus as, so 1 minus e to the power minus as by 1 plus e to the power minus as. Now if you multiply on numerator and denominator e to the power as by 2, then what will you get? E to the power as by 2 and minus, this will produce e to the power minus as by 2, and what will it produce? E to the power as by 2 plus e to the power minus as by 2. And you see, if you divide by 2 here on the numerator, if you divide it by 2 on the denominator, this will become sine hyperbolic as, this will become cos hyperbolic as, so it becomes tan hyperbolic as by 2. So k by s tan hyperbolic as by 2. So in this way we can easily tackle problems based on unit step function. So I hope you have understood this. K by s tan hyperbolic as by 2. So this is Laplace transform of this function. So if you have any query, question regarding this unit step function, you can let me know in the comment section. I will try my best to clarify them all. And let me just tell you guys, I also teach on Unacademy. I teach on CSIR net, UGC net category physical science. So, and a lot of new courses are going to start in the next month, and a lot of courses are currently ongoing in the present month. So you can visit my profile on Unacademy. You can just go to unacademy.com and you can search with my name Sahin Sorifi and will get my profile, and in that profile just try to enroll for the upcoming courses or present courses. And if you are not an Unacademy Plus subscriber, you can take Unacademy Plus subscription using our referral code PhysicsHub, and Unacademy will give you 10% off on overall fees. So this is all for today, and hope you have liked the video, and if you like it, please give it a thumbs up, and if you're new visitor to this channel, subscribe to the channel and don't forget to press the bell icon. And finally, thanks for watching.